Okay, guys, we are in Advanced Honors Math, Mods 2, 3, and 4. It is Tuesday, April 7th, 2020. It's our last day of conic sections. If you recall, we did circles, we've covered ellipses, we worked on hyperbolas yesterday. Our final topic for conic sections in terms of what type we're going to graph are called parabolas. Yes, that should sound familiar. Yes, you have graphed parabolas so far this year. Let me recall something for you here. First of all, again, as always, let's have a note-taking session. The title of today's notes is simply Parabolas. The date is April 7th, 2020. We're going to do these 4 problems that are fairly basic parabolas, and then just like we've been doing the last 3 days, attack a 5th problem involving us doing a lot of algebra to get it into standard form before we actually go ahead and graph it. I do want to make a side note. You do not have to write this down on your paper, but if I pointed something out here that we've done in the past in terms of functions, let's say I gave you the function y equals x squared minus 3x minus 4 and said, hey, everybody, let's graph that quadratic function. You guys will recall that you would find the vertex by using the formula, remember, negative b over 2a. You could factor it, set those 2 factors equal to 0, and find your 2 x-intercepts. And bottom line is, y was by itself, meaning it was a function, and when the x was squared, we knew it was a parabola. In this case, because it was a positive x squared, it opened up. If that would have been a negative x squared, it would have been a parabola opening down. But the point is, those were parabolas. We called those officially quadratic functions. Well, today our goal is to graph quadratics or parabolas in a little bit different format, a different type of standard equation. And notice on this first one, we've got x squared equals 8y. The second one, we've got x minus 1 squared equals negative 4 times y plus 2. And as we look ahead to problems 3 and 4, they switch things up on us. The y is squared in this one. And in the last one, it says y plus 1 squared equals negative 2 times x minus 3. So my first important teaching point is it's easy to tell, oh, that's a parabola, as opposed to circles, ellipses, and hyperbolas, because remember on those 3, we had an x squared plus or minus, and then a y squared, and both letters were squared. Obviously, my first point is if you just see an x squared and the y is not squared, or if you see a y squared and the x is not squared, that's an indicator I'm about to draw a parabola. Okay, point number 2. As I just pointed out, when we saw y equals x squared, that was a quadratic function and was a parabola that opened up or down. So my first teaching point is, when you see the x as the letter that's squared, it's a parabola that's going to open either up or down. Okay? So first of all, let's decide which direction for sure this number 1 is going to open. It says x squared equals 8y. I just said if the x is the letter that's squared, it opens either up or down. And because it's equal to a positive 8, in this case a positive 8y, oh, this parabola is of course going to open up. So we're picturing a smiley face, correct? Well, think about it. If I'm about to draw a smiley face on my paper, I need to know where is the vertex or the center located. And wouldn't I need to know about how wide to make the parabola I'm going to sketch? So those are the 2 key things we're going to focus on when these parabolas today are in standard form. Now, standard form is indeed the x squared, the x squared, the y squared, the y squared by itself. You want the squared term to be by itself. And on the other side, you want some kind of a constant that's attached to the letter that's not squared, just like you see on this first one, x squared equals 8y. Okay, first of all, I'm going to put V for vertex instead of C for center. The vertex, very similar to what we've been doing the last several days, since it's plain old x squared. Now, even though there's a dot connected 8 in front of the y, it's not like y plus 2 or y minus a 1. The y doesn't have a number plus or minus connected to it. So my x, since it doesn't say x minus 1 or x plus 2, and my y, since it doesn't say y minus 1 or y plus 2, something like that, they are considered to have a vertex or a center at 0, 0. So 0, 0 is going to be the center of my parabola. So when I go to draw this, my vertex is at 0, 0, right on the origin. I'll put V for vertex instead of CR for center. Now the question is, well, we know it's opening up. Now the problem is, if I told everybody, go ahead and draw a smiley face right now, you don't know how wide to draw the smiley face, do you? So all you've got to do next, once you know the direction that it's pointing and the location of the vertex, is you take the following formula every time. The formula you have to memorize is 4p. You always take 4p, no matter what, and set it equal to the number or the coefficient that's in front of the letter that's not squared. So in this case, the y, which isn't squared, has an 8 in front of it. So you take 4p, set it equal to 8. Obviously, when I divide by 4, I end up with p equals 2. Now, why do they use the letter P? Because what we just found is what's called a focal point. Okay, it's a focal point. We'll call it the focus. The focus is 2 units up from the vertex. Oh, it kind of falls into place here. My focus is 2 units up from my vertex. So if you write down the direction it's pointing, it helps you to remember which direction you're going to draw that important focal point we just discovered. So guys, I'm going to go up 2. I'm going to put a dot. I'll put a P there for my focal point. And that dot, the reason it's important is I'm about to draw an imaginary line through that focus that tells me how wide to make this parabola. Well, guess how wide the line is that I'm imagining through this focus? It's equal to 8. Whatever that coefficient is how long the length of this segment is that I'm imagining. So careful, if that's an 8, there is a line going right through this focus that's 8 inches long, or 8 inches wide. Now careful, it's a total of 8. So you go to your focus, and you're actually going to move 4 to the right, and then move 4 to the left. Oh, and now I know exactly how wide to draw my parabola. And I'm done. Okay, that's the general idea. So let's shoot over to number 2 here. X minus 1 squared equals negative 4 times y plus 2. Okay, first of all, let's write down the direction, the vertex, and the size of the focal point. That's all you got to do. All right, number 1, the x is the letter that's squared. If the x is the letter that's squared, it opens either up or down. Since my coefficient, negative 4, is a negative number, that tells me I'm about to draw a parabola facing down. His vertex is at, and just like the last few days, that says x minus 1. The opposite of minus 1 is, of course, plus 1. And if that says y plus 2, the opposite of that would be negative 2. So my vertex is at 1, negative 2. So I'm going to draw a picture. I'm going to go right 1 and down 2. That's a V for vertex. I know that there's my vertex at 1, negative 2, and I know that the parabola I'm about to draw is pointing down, isn't it? We've already said that. How far down am I going to draw it? Well, every single time you take 4p, that's your formula, set it equal to whatever that coefficient is. In this case, -4. We end up with p equals -1, right? Because you divided by 4 to get p by itself. Oh, I have a focal point that's located -1. It's negative because it's 1 unit down from my vertex. So I'm going to go to my vertex. I'm going to go from my vertex down 1. And I'm imagining, it's almost like you're picturing an imaginary line going right through this focal point. That's what? 4 inches wide. The negative's irrelevant, of course, when we look at how wide it is. It's the absolute value of that number. So since there's a 4 in front, the segment I'm imagining is 4 inches total. So actually, I'm going to go to my focus, not my vertex, go to my focal point and go right to and left to. If you want to draw a very light line through there, that's fine. That's what you were imagining. That's how wide my downward parabola is. And it looks like that. Okay, pretty cool. Now, obviously, you juniors, when you get to AP Calculus next year, you're going to take something like that. You're going to rotate it or spin it around its axis of symmetry. You'll end up creating, a three-dimensional shape that looks like that. And Mrs. Moser's going to ask you, hey, I wonder what the volume of that shape is. It kind of looks like, what, a wine glass maybe? If I turned it upside down and said, oh, look at that, it's a wine glass. Or it's a cereal bowl. How much milk does that thing hold? Well, I'm asking, of course, what's its volume? And we don't know what the volume of a milk or cereal bowl is, do we? We don't have a formula for that from geometry. So you use calculus and learn how to answer questions like that. And it all depends on accurately and correctly drawing the parabola to begin with. Okay? Third block. Uh-oh, I noticed right away the y is squared. So guys, if then yourself. If the x squared meant it opened either up or down, when the y is squared, my parabola is going to open either left or right. And again, I look to the right of the equal sign and I see a positive 12. Positive, of course, is the right-hand direction. Negative would be to the left. So this is a parabola opening to the right. Does everyone agree? The vertex, or the center, is at, now careful, my x value is over here on the right and my y value is on the left. So you got to look in the correct order here. When I list the vertex, it's not 0, 1, is it? There's my x. It's actually 1, 0. So I've got my vertex. I'm going to go to draw my picture here. I'm going to place my vertex right there at 1, 0. And I know I'm going to draw a parabola pointing to the right. So the question again becomes what? I wonder how wide this parabola is. So just like the other two, I take 4p, this time set it equal to 12, divide by 4, and p would be 3. Now guys, follow the bouncing pen here. What does that mean, p equals 3? I have a focal point that's 3 units to the right of my vertex. I have a focus that's 3 units to the right of my vertex. So I go right 3, put a dot. This was my vertex. This is my focus. My parabola I'm picturing is pointing to the right. So I'm picturing a parabola pointing to the right. The question is it a really wide, big parabola or a little tiny baby parabola? Oh, I look at the number up here and I see a 12. Whoa. So there's an imaginary line running through this focus that's a total of 12 inches tall. Total of 12, so don't go up 12 and down 12. But oh my goodness, that does tell me to go to my focus, go up 6 and down 6, and connect them up. and you got a really wide satellite dish facing to the right. Okay? And then the last one on the front of my paper, y plus 1 squared equals negative 2 times x minus 3. Okay, here we go. Here's your logical thought process. Watch how simple when you attack your assignment. My y is my letter that's squared, telling me it opens either right or left. Since it's a negative coefficient here, it's going to be to the left. So left is the direction of my parabola. The vertex, again, be careful. That says x minus 3. So I'm going to write 3, comma. It says y plus 1, so I'm going to write negative 1. So my vertex is 3, negative 1. I draw a picture. I'm going to go right 3 and down 1. There's my vertex. I know my parabola is facing the left or pointing to the left-hand direction. I'm not sure how wide to make it. Oh, I better take 4p every time. Now notice this time, I'm setting it equal to the number in front, like always, which is negative 2. So p is only going to be what when I divide by 4? Negative 2/4, which is negative 1/2. So follow the bouncing pen again. I have a focal point that's 1/2 unit to the left of my vertex. So I only go left 1/2 inch, put a dot, there's my focus. The line running through that focus, measuring the width of my parabola, is only 2 inches total. So that's obviously up 1 and what? Down 1 from that focus. Aw, so we've got a little baby tiny parabola facing to the left. Okay? Not bad. Finally, last problem. I ran out of room, so I'm going to flip to the back of my paper. And I'm going to try this problem right here. Just like the last 3 days, we will end the session trying to do a problem that is currently not in standard form. As you look at this problem, let's say you were taking the ACT test and you see this. Oh, there's only one letter that's squared, not 2 letters squared. So it's not a circle, it's not an ellipse, it's not a hyperbola. Hasn't our goal been to get the x squared value by itself on every one of these? The squared has been by itself, but I notice there's a 4x that's part of his family. So bottom line is, watch this, guys. When I reorganized and do some algebra here, I'm going to go x squared plus 4x, leave a blank space. These numbers here, the 6y and the minus 2, are both going to get shoved out of the way. Because remember, our goal on a parabola is to get the squared value by itself. So if I minus over the 6y and add over the 2, I, of course, have negative 6y plus 2 on the right side. Completing the square, like we've done the last 3 days, if I cut 4 in half, that's what, 2? 2 squared gives me 4. And whatever I do to one side, I do to the other. So just like always, when we complete the square, cut the middle number in half and square that answer. Cleaning this up now. Do you agree that this is now a perfect square trinomial? I would break it into x plus 2 times another x plus 2, so it's really x plus 2 squared equals negative 6y plus 6. Almost done. Last step, and it'll be in standard form. Do you agree that on the other side, if you look at all the problems we've already done, look, oh, I want a coefficient to be out in front of a quantity. I want a coefficient in front of a quantity. So this problem right here, I'm going to factor out the negative 6 as my GCF, leaving me with y minus 1. Agreed? Is it negative 6 times y, negative 6y, and a negative 6 times a negative 1 is a plus 6. There, it's in standard form. I want you to go ahead and finish. See if you can now graph this, because we didn't know what was going to happen. If I said, quick, let's graph this parabola. Okay, which way is it opening? I'll give you a second to think about it. Since the x is squared, it's either up or down. Since that's a -6, it's going to open down. Agreed? My vertex is at, okay, I have x plus 2, so that's -2. Y minus 1, so that's 1. So I'm going to go left 2, up 1. That's my vertex. I'm picturing a parabola that's opening down, so it's a frowny face. Take 4p, set it equal to what? -6, dividing by 4. P would be -6/4, which is what? -3/2. Agreed? So that's -1.5. So I'm actually going to go down. I got a focus, guys. I have a focus that's 1.5 down from my vertex. Your focus is always in the direction that the parabola is going to point. So I go to my vertex, I go down 1.5. That's my focus. I'm picturing a parabola pointing down. The only question is, how wide is it? Oh, well, I look, my coefficient is a 6, isn't it? So it's 6 inches total for the width. So I'm actually going to go to my focus and go right 3 and go left 3. Now I know, excuse me, exactly how wide to make it. Okay? All right, I think you got it. Let's see if you do. Today is Tuesday the 7th, so you owe me this assignment, these problems right here, by what? Noon on Wednesday the 8th. So again, this is the assignment for April 7th on Tuesday. It's due Wednesday, April 8th at 12 o'clock. Try graphing all 5 of these. The 5th one, of course, you can't graph till you practice putting it into standard form. So my problems are as follows. Hit pause if you need to and copy these down. X squared equals -8y. X plus 2 squared equals 6 times y minus 1. Number 3, y plus 1 squared equals 8x. Number 4, y minus 2 squared equals -4 times x plus 1. And finally, the last one that you're going to have to complete the square to get into standard form. Be careful on that one. X squared minus 2x plus 8y plus 9 equals 0. All right, great job, guys. Those are due tomorrow at noon. Tomorrow on the 8th will be our very last section of notes for the chapter on conic sections. And we'll actually do systems of conic sections where we're trying to see where 2 different ones are going to intersect each other, because those are important points when you do a little bit of calculus for next year. Okay? Great job. We'll see you tomorrow.